Okay, so scientific notation is great because you don't have to write really, really big numbers or really, really small numbers. You can do it in a quick way to write the numbers, and that's why scientists don't want to sit there writing a bunch of zeros or writing a bunch of numbers. So they do this quick way of writing numbers, and it's called scientific notation. The big idea with scientific notation is the decimal has to be right after the first non-zero digit. First non-zero digit. Let me write that. Okay, that's where the decimal belongs in scientific notation. So they put the decimal right after the very first non-zero digit. Okay, so let's look at number 1. We have 27,001. So from left to right, you're looking at the numbers. We have 27001. What's the very first digit that is not 0? It's the 2. So we're going to put the decimal after the 2, and then we rewrite every single other digit that's there. Okay, so I'm going to rewrite the 7001. And now scientific notation always has times 10 to the something power. Okay, well, look at that small number, 2.7. Multiplying it by what is going to give us 27,000? By a big number, right? If you have like $2.70, you need to multiply it by a big number to make 27,000. Okay, so this number times 10 to the something power, there's going to be an exponent here. That's going to be, I know it's going to be a positive exponent, because if it were a negative exponent, that would turn this number into a really small number. And I'm looking to make it equivalent to 27,001. So the way you find how the exponent is, you see how many digits did the number, did the decimal move. So it was here, right? Because that's, if there is no decimal in a number, it's at the end. And now it's 1, 2, 3, 4. It's right there. 1, 2, 3, 4. So that is your exponent. Let me write it right here. So this becomes 2.7001 times 10 to the 4th power. So scientific notation will always have the decimal after the first non-zero digit, and it's always something times 10 to the something power. Okay, so when you're looking at number 2 is a really small number, right? It's tiny. So that's the first thing I like to think of. And then looking from left to right, is the decimal right after the first non-zero digit? No, it needs to be moved over to right after the 3. So you rewrite, you write 3.4156602. You don't need the very last zero. Any zeros at the end, you don't have to write. And then we always will do times 10 to the something power. What would we have to multiply by to turn 3.4 into 0.34? If we multiplied by a big number, 3.4 would become bigger. So we technically need to multiply by a smaller number. So that's how I remember it. A lot of teachers teach, oh, if you move it to the right, it's positive, and to the left, it's negative. But that switches depending on if you're writing a number from scientific notation to standard form, or to standard form to scientific notation. So I kind of just like to use my knowledge of numbers. 3.4, in order to make that 0.34, I'm going to need to multiply it by a small number. So that exponent is going to be a negative number. And the number is just going to be how many times did we move that decimal? We moved it once. So that is -1 for our answer, 10 to the -1. And double check, is the decimal after the first non-zero digit? Yes. And will 10 to the -1, that will move the decimal to the left 1, and that's what it says on number 2. Okay, and I know that these are a little tricky, so just keep with it. Okay, so the number 3 says 0.0089. Well, I know that my decimal has to be after the 8, the first non-zero digit. So I'm going to write 8.9 times 10 to the something power. First off, ask yourself, is that exponent going to be positive or negative? What's going to take 8.9 and turn it into 0.0089? That's got to be a negative exponent. You can't multiply by a positive exponent. 10 to the something power is only going to make it bigger. Okay, and then how do we get that exponent? We count how many places did we move the decimal. 1, 2, 3. So that becomes 8.9 times 10 to the negative 3 power. Okay, looking at number 4, 134. Where is that decimal right now? It's after the 4. Just like when we write money, $134, sometimes we don't write the decimal and the zeros after it. So right now it's after the 4, and where do I need it to be? I need it to be after the 1. So I put 1.34 and then times 10 to the, look at what we have here. We have 1.34. What kind of a number would we need to multiply by to turn it into 134? A big number. Has to be a positive number. So that's how I know my exponent is positive. So how many times did I move the decimal? 1, 2. So my exponent is a positive 2. And just to double check that, 10 squared, 10 to the second power, isn't that 100? Right? So 1.34 times 100 is, when you multiply by 100, you just move the decimal twice to the right, and that's how you get 134. So you can double check your work that way. And it's okay to get these exponents wrong in the beginning. Just fiddle with it, double check your work and say, oh, I should have made a negative, or I should have made it positive. Okay, looking at number 5, 901,034. So we know our decimal is here. Where do we want it to be? 1, 2, 3, 4, 5. And if you're getting the hang of it, pause the video and test yourself. Okay, so I'm going to rewrite this as 9.01034 times 10 to the something power. So looking at our number that I wrote, 9.01. So we have like a 9. What will turn 9 into 900,000? A big number. So this exponent is going to be positive. And how do I find it? I count how many places I moved the decimal. 1, 2, 3, 4, 5. And that is the exponent of that one. Okay, and then the last one, I have 0.000004. That's a super tiny number. So where does the decimal belong? It belongs after the 4. So 1, 2, 3, 4, 5. We're going to have to move it 6 places. Okay, so I could write 4.0, but 4.0 is the same as 4. So I technically, some teachers might want you to write the 0.0. I'll actually write it and then I'll rewrite it as just 4. So 4.0 times 10 to the, so looking right here, we have 4. What are we going to do? What are we going to multiply by to turn it into this tiny number, 0.000004? We're going to have to multiply by 10 to the negative power, because that's going to give us a really small number. Okay, because it's just like dividing. Okay, and then what is our exponent? 1, 2, 3, 4, 5, 6. We moved it 6 places. So 4.0 times 10 to the negative 6. And you might see it just 4 times 10 to the negative 6 power as well. So that was the intro to scientific notation. Hope it helped.